Hello everyone, my name is Manohar. I am a data science trainer and consultant. Today we are going to discuss about deep learning and its future trends. Let me tell you agenda for this discussion. In this discussion, we discuss deep learning introduction and working of deep learning. After that, we discuss about how we can differentiate human brain to the artificial brain. And then we discuss about frameworks in deep learning. Later, we discuss types of learnings in deep learning and architecture of deep learning. And in the end, we discuss applications and implementation of deep learning. Firstly, let me start the session with the disadvantages of machine learning. First, data acquisition. Data acquisition is one of the most painful find in the field of data science and machine learning. Additionally, collecting data comes with a cost. Also, it so happens that when we are collecting the data from surveys, it might contain a large amount of bogus and incorrect data. Many times we do face a situation where we find an imbalance in data which leads to poor accuracy of models. These reasons make data acquisition a massive disadvantage. Next, highly error prone. Garbage in, garbage out is the thing to always remember in this technology. The data we push in the models as training data must be clean and accurate for the problem we are solving. Being easy to automate process using machine learning, it sometimes just happens that the data in between is improper. This might cause incorrect results or errors. For example, we might witness a situation where customers may be classified as defaulters or customers or recommended products not related to their search history. Next, algorithm selection. A machine learning problem can implement various algorithms to find a solution. It is a manual and tedious task to run models with the different algorithms and identify the most accurate algorithm based on the results. This is a disadvantage. Next, come to the time consuming. Machine learning models are capable of processing huge amounts of data, larger the volumes of data and the time taken to learn and from data and process it also increases. Sometimes it might also mean additional resource for computing. Since machine learning occurs over time as a result of exposure to massive data sets, there may be a period when the algorithm or interface just isn't developed enough for your needs. In other words, machine learning takes time, especially if you have a limited computing power. Handling tremendous volumes of data and running computer models sucks up a lot of computing power, which can potentially be quite costly. So, before turning to machine learning, it's important to consider whether you can invest the amount of time and money required to develop the technology to a point where it will be useful. The precise amount of time involved will vary dramatically depending upon the data source, the nature of the data, and how it's being utilized. Therefore, it's wise to consult with an expert in data mining and machine learning concerning your project. Next, interpretation. When the algorithms helps in all these processes and gives a resulting output, this given output must be checked for any errors and the correction operation should be followed to get the desired accuracy. And during the selection of algorithm, we must select that algorithm which you require for the purpose. Next, image recognition. Machine learning can't recognize the images and also it can't classify the images. To overcome all these disadvantages with machine learning, deep learning came into the picture. Let us know what is the difference between machine learning and deep learning. Deep learning is actually a subset of machine learning. Hence, often the two terms are confused by people. However, they differ in their capabilities. That's why it is necessary to know about machine learning while reading about introduction to deep learning. Machine learning models lack the mechanism to identify the errors. In such cases, the programmers need to step in to tune the model for more accurate decisions, whereas deep learning models can identify the inaccurate decisions and correct the model on its own without human interventions. But for doing so, deep learning models require large amount of data and information unlike machine learning models. Let us discuss how human brain differs from artificial brain. A nerve cell, neuron, is a special biological cell that processes information. According to estimation, there are huge number of neurons, approximately 10 power 11, with numerous interconnections and approximately 10 power 11. As shown in the figure, a typical neuron consists of the following four parts, with the help of which we can explain its working. Firstly, let me explain about dendrites. They are tree-like branches responsible for receiving the information from the other neurons it is connected to. In other sense, we can say that they are like the ears of the neurons. Next, soma. It is the cell body of a neuron and it is responsible for processing the information they have received from dendrites. Next, axon. It is just like a capable of through the neurons send the information. And finally, synapses. It is the connection between the axon and the other neuron dendrites. The term neuron hails from the name of the nervous system basic unit called neuron, and hence a network such as called neural network. That would be the network of neuron is a human brain. Artificial neural networks can be best viewed as weighted directed graphs, where the nodes are formed by the artificial neurons and the connection between the neuron outputs and neuron inputs can be represented by the directed edges with weights. The artificial neural networks receives the input signals from the external world in the form of patterns and images in the form of vector. Each of the input is then multiplied by its corresponding weight. Weights are the details used by artificial neural networks to solve a certain problem. In general terms, these weights typically represent the strength of interconnection amongst the neurons inside the artificial neural networks. All the weighted inputs are summed up inside the computing unit. The activation functions, in general, is a set of transfer functions used to get the desired output of it. There are various flavors of the activation functions, but mainly either linear or non-linear set of functions. Some of the most commonly used set of activation